Hi everyone, this is Aarohi, and in this video I'll show you practically how to implement faster Rcnn step by step. See, the very first step is data, the data which we need to train our algorithm. So we need to prepare our data in the format which faster Rcnn accepts. So which format faster Rcnn accepts? So here you can see the very first thing is file name and then xmin, xmax, ymin, ymax, and finally the class name. In this snippet also you can see this is the snippet of my data set. So under file name we are having the images, and xmin, xmax, ymin, ymax are the coordinates of bounding boxes, and finally we are having a class name. So we need to prepare our data set in this format, right? So the data set which I'm going to use today for today's example is open image dataset. So this dataset is easily available on internet. You can see over here, this is the dataset. Okay, so from this dataset, this is open image dataset. I'm using this dataset for today's class. Basically this dataset is very huge and have images in millions and have around 600 different classes, right? So no, I'm not going to use this whole data set, right? What I'm going to use is I'm going to use the subset of this data set. I will be showing you this example by working on 3 different classes. Instead of using all 600 classes, this will slow down our process. So I'm going to use 3 or 4 classes, and on the basis of that, those 4 classes, I'll show you the task of object detection. So let's begin. So the very first thing is, first of all, I'm importing all the required modules, right? Once you import all the required module, next thing is data. We need to download the data on which we want to train our algorithm, right? And then first of all we'll download the data, this Imagenet data which I just told you, like the data set which I'm going to use today. Once we download that data, then I'll convert that data in the format which faster Rcnn accepts. Alright, and which format faster Rcnn accepts? This format. Alright, now let's execute all the steps. So after importing all the modules, the next thing is you'll see one URL over here, right? So we need to download 3 CSV files from that open image dataset. These URLs I have mentioned, all these URL in description section. You can simply copy from there, right? Just copy the URLs from description section and you can directly download from internet. And if you want to download these datasets using this Jupyter notebook, then you can simply import wget, right? And then write the URL name, and by using this command you can directly download that particular data in the current working directory, right? So this is my first file, and this is the second file which I'm downloading, and this is the third file of the dataset, right? So if you'll see, all these 3 files are CSV file. This is also a CSV file. Here also I'm using a CSV file, and this third file is also a CSV file. Alright, now what all these files are, what is present in these files, why we are downloading these files. So I'll explain you one by one. The very first file, this train annotation boxes, right? What this file is? This file is basically containing the bounding box information with image name and image label. I'll show you, okay? I'll show you in a minute. Over here you can see this. We are talking about okay, first of all, you see here I have created 3 variables, and in these 3 variables I'm storing these 3 files. Why I'm writing like this? Because after downloading these files got downloaded in my current working directory, right? So, and in these 3 variables I'm storing these files. Now I can directly use these variables to access these files, right? So the file, I have one variable with the name of image boxable file. In this variable, in this variable I'm writing this file. Alright, train image boxable with rotation. Now train image boxable with rotation, what it contains is, it contains image name and image URL. Image name and image URL, let me show you here. Image name, just give me a second please. See, image boxable. What I'm reading over here is, I'm using pandas.read CSV and I'm reading this file which is present in image boxable file. And what is present in image boxable file? This CSV file, right? So you can see over here, this file is giving us detail of image, means it is telling us image names and image URL. This is the original URL of image, this is original landing URL of that image, and the other detail of that image. All right, so this is the first file. Then we have stored our second file, this train annotation boxes, in this variable. Now let's see what is there in this file. So you can see over here, we are reading this file again using pandas.read CSV, and by using this head method of pandas, we are just viewing the first 5 records of this file. And you can see over here, this annotation file, this file contains the bounding box information. Bounding box information simply means this xmin, xmax, ymin, ymax. These are the 4 important parameters. By these 4 coordinates only we are generating the bounding boxes. And this file also have some other things like is occluded. What is this occluded? Occluded simply means that one object is blocked by another object. So for example, one object is chair and the other object is table. Suppose we have an image where chair is partially under the table, right? So here we can say that this chair object is occluded by table. All right, so in the same way, it have another column with the name of is truncated, right? Now is truncated means the object extends beyond the boundary of image. In the same way, there are other things, but the important thing is this bounding box coordinate, right? This file is containing the bounding boxes. And then we have file with the name of class description. Class description will simply tell us the label and the class name, right? So these are the 3 different files which we have downloaded. And now what we want is, now in this next cell I'm writing a function to plot a bounding box, right? So in one file we have images and details of images, and in second file we have details of coordinates of bounding boxes, right? Now what we will be doing, we will use the images of first file, and using the coordinates from second file will plot a bounding boxes on the image. All right, so in this function what we are doing, we are using the 2 CSV files out of 3 CSV files which we have just downloaded. We are using those 2 CSV files, and the first file which I have just shown you, which is saved under images boxable, which is having the detail of images, right? And the second file is annotation file, where we have a detail of bounding boxes. And we are using these 2 files. And finally I'm using a cv2.rectangle function for drawing a rectangle on the objects and putting text on the box, right? Let me show you how. So this is the function. Here I'm defining one function, and the function name is plot box, and we are passing one argument to it, right? This is image ID. This simply means whenever we want to use this function, we need to provide the image ID to this function, means on which particular image we want to plot, we want to draw the bounding boxes, right? So this is the important parameter we need to give it, right? So as I've just told you, in this variable, what I'm doing over here is I'm getting the images which are present in image boxable variable. And with what is present in image boxable, I have just shown you image boxable. So here, so image boxable is a variable where we are reading this image boxable file which have detail of images, right? the proper URLs of images and all other details of images, right? So first of all, we are reading a image, and then see, these are the basic things, like means in these three variables I'm storing height, width and channel of image, right? And now so these 3 or 4 lines of code is for reading a image from image file and storing that image detail in different variables. Now we are using this annotation box variable. This is again a variable which I have mentioned above, which is reading annotation bbox. This is reading a annotation file which is having a bounding box coordinates, right? So we want to draw a bounding box on our objects, so we need these coordinates, then only we can draw a bounding box. So that's why we are using the CSV file over here, and from this line it will get an image ID, right? Once you get the image ID, by using this xmin, xmax, ymin and ymax, we will plot a bounding box, and cv2.rectangle will help us for drawing this bounding box. And what is here, these are the important parameters which you need to give when you want to use this cv.rectangle method. First is image, the image on which we want to plot a bounding box, and this is the starting point of the bounding box, xmin, ymin. This is the end point of the bounding box, and then this is the color of bounding box, and finally we are having a thickness of bounding box, right? So this will draw a bounding box, and then after drawing a bounding box on object, we want to write the text on it. So we can write a text by using this put text method. By using this put text method, we will write a class name on it, right? And then these are again the important parameters while writing your class name. And finally we are plotting a bounding box. All right, now we have created a function. Now let's use this function and see how it gives us results. So over here in these 3 lines, I'm fetching the IDs, and after fetching the ID, I'm using the function, this function plot bbox. This is the function, right, which I've just created, plot bbox. So I'm plotting a function, I'm using a function, and I want to plot a bounding box on this particular image ID. And you can see over here, it will show you like this is vehicle in this first picture, and the second picture it is showing us a fish. So this is how this bounding box function will work. Now next thing is to choose a subset of this data set. So see, I have told you in the beginning of today's class only that I will work on only 3 classes, because this data set is very big, and there are around 600, there are 600 categories or classes present in this data set. So we are only going to use 2, 3 or 4 classes from them, right? So over here, this is what I'm doing. First of all, this class description is a variable which I have mentioned above, and this class description is storing the data. Let me show you this class description variable first of all. So over here, class description is a variable which is reading a file which is present in class description file, and the file which is present in this class description file, this is one of the file which we have downloaded. All right, and the data which is present in this file is this. It has 2 columns. The first column is containing a label, and second column is containing a class name. This is label of image, and this is class name of image. All right, now what I'm doing is, so see, first of all, I'm just showing you by using a count, like how many different categories are there. So we have 601 different classes present in it, but out of those 601 classes, I want to have data which is related to bed class, chair class and table class, right? So I have created 3 different variables: bed underscore pd, chair underscore pd and table underscore pd. So in these three variables, I'm storing data which is related to bed. I'm storing that in first variable. The data which is related to chairs, I'm storing that data in chairs PD, and the data which is related to table, I'm storing that in table PD. After that, I'm just showing you the one. I have printed the result of this so that you can get an idea like what kind of output you'll get. So we are getting the data which is related to bed only. So this is a class name and this is a label for bed. Okay, so in my next cell over here, we are separating the labels. All right. So why we are separating the labels? Because in next step we have some functionality to perform on labels, so that's why we are separating the labels from this file. So I have three variables for this. So separate label for bed, chair and table, and we are storing the labels in it. And after that, I have printed the result of first one, and you can see over here, this is the label which we have for bed. Right, so we have separated the labels and all the labels are stored in these three variables. Right, now in this cell here, we are storing bounding box coordinates separately for bed, chair and table class on the basis of label name. Right, the labels which we have separated over here, on the basis of those labels, see, these are the variables which are storing labels separately for bed, chair and table. So on the basis of these three labels, we are storing the bounding box coordinates of bed, chair and table class separately, and we are storing the bounding box of bed in bed underscore b box, and the bounding box of chair in this, and bounding box of tables in this. Right, so basically what we have done over here is we have separated the records on the basis of class, and we are working on these three classes. So I have created three different variables, and in these three different variables I have saved the data of the three different classes. Now the next step is, let's see how many records are there in belongs to this bed, and how many records are there which belongs to chair, and how many records are there in table class which how many records are there in a data set which belongs to table class. So when we printed, so this is what we got. So we have 3563 records in this data set. Means in this data set, whole data set, we have 3563 images of beds, records of beds, and 1,32,483 records of chairs, and 85,691 tables in our data set. Okay, so now the next thing is, now okay, in this cell you'll see I'm storing the IDs separately. The IDs of image ID of bed B box. Image ID means this column. Let me show you image IDs. I'm storing all the image IDs which belongs to bed in a separate variable, and all the image IDs which belongs to table class in a separate variable, and all the image IDs of chairs in a separate variable. Here, see the data which belongs to bed, this bed bounding box image ID, I'm storing it in a separate variable, and chair image ID is a variable where we are storing the image IDs belongs to chair class, and table image ID is a variable where I'm storing the image IDs which belongs to table class. Right, now as you have seen over here, so there are so many images, right? So we have lots of images in these three classes again. So but in my today's class, I'm just trying to explain you the concept, so we are not going to use all these images. What I'm doing is I will only pick 10 images of each class, means 10 images of bed, 10 images of chair, and 10 images of table, so that our algorithm will work fast and it can show you the results sooner. Right, so in this line, this is what I'm doing. I'm only picking 10 records from each class, and I have created a variable with the name of n, and I've written 10 over here. So in this first line, what I'm saying, that pick any random 10 IDs which belong to bed image IDs. So what we have in bed image ID, the image IDs, all the image IDs which belongs to bed class, we have stored that in bed image ID. So over here I'm saying that randomly pick 10 image IDs of bed from this variable and store it in subbed image ID. In the same way, pick 10 random image IDs of chair and store it in subchair image ID, and randomly pick 10 image IDs of table and store it in this. Now what we have in this subbed image ID and all these three subbed image this bed, chair and table IDs, 10 images. All right. Now over here in next line I'm saying that in these three variables I'm storing the data, whole data, which is related to this image ID, right? So basically what we are doing is image boxable is a variable, right, which is having all detail of images. I have shown you above also. So this is a variable which is having full detail of image, means the name of image, image ID, original URL and original landing URL, everything over here. What we are saying is from this variable, from this particular file, check all the IDs. Isn't means the IDs, the 10 IDs which we picked from here, those IDs, get the data of those IDs and store it in this. Get the data of subchair image ID and store here, and get whole data which is related to sub table image ID and store it in this. Now in these three variables we have full data of those 10 image IDs, and over here I'm printing the shape also of these three variables, and you can see we have 10 records in each variable, and each shape is 12, means every row has 12 columns. Okay, so I have shown you one file over here. I've shown you the first record over here, you can see. So we have 12 columns and 10 records. So I'm using head over here, that's why we are getting the first 5 records. All right. Now till now what we have done, see, first of all I have shown you we have downloaded the data. Once we download the data, then we created one function. That function is used to plot the bounding boxes, and then we have used the subset of data, means we have only chosen bed, chair and table class from whole data set, and then after choosing bed, table and chair class, we get to know like there are lots of images present in these three classes, and this will slow down our process. Then I have chosen I have told you to just pick 10 images from all the three classes, so that we can perform the functionality fast, right? Now the next step is over here I'm creating a dictionary, and in this particular dictionary I'm only taking image ID and the original URL of that image ID, and then I'm setting index. Why I'm setting the index? Because now we have picked very few records from the all record, and all the records get shuffled and all, so just to that's why I'm using set index. In the same way I have created a dictionary for chair and table and then set the index. Now I have a variable with the name of mapping. In that mapping variable, this is basically a list, and I have stored all these three variables in it, and then I'm checking the length. Obviously we'll get 3 over here because we have 3 different dictionary items in it, and over here I'm checking length mapping 0. Mapping 0 simply means this is at 0 index, right, of mapping dictionary. This is the item at 0 index, and how many records were there in this item? 10 records. Why? Because as I've told you, we are only using 10 images for each category, so that's why. So I have created one more list, and in this list I'm writing bed, chair and table. These are the three classes which we are working on today. All right, now this loop, what we are doing in this loop, see, after executing this code we will be having three different folders in our current working directory, and the folders which we will get after the executing this code will be bed, chair and table. Bed, chair and table are three different classes, right? So we will get three different folder, and in each folder you will get 10 images. Let me show you. See over here, bed folder, chair folder and table folder. When you'll open this bed folder, you'll get 10 images which belongs to bed, and when you'll open chair folder, you'll get 10 images which belongs to chair class, and when you'll open table, you'll get 10 images which comes under table class, right? So we have 10 images now. And if you'll see over here, see, rest of the files you will be familiar with right now, and rest of the files, you know, I'll tell you in next few minutes, like from where we get those files. So if you'll see this CSV file, this CSV file and this CSV file, these are the three CSV files which we have downloaded in the beginning from the Imagenet dataset. All right, this and this, and bed, chair, table are the folders which we have just created by executing this code, and we have 10 images each. Now we have 10 images, and on those 10 images we want to train our network. So if you remember from the very, you know, when I started today's lecture, in the very beginning I've told you that faster Rcnn accepts the data in this format. Now we will convert our data in this format. So for that, first of all, we are creating two different folder, train folder and test folder, because on the basis of training data, the data which will present in train folder, on the basis of that we will train our algorithm, and the data which will be present in this test folder, we will test our algorithm on it. All right, so you need to create these two folder, train folder and test folder. So if you'll see over here, I have created test folder and train folder, right? This train and test folder will have 80% of the data. So we have 30 images in total, 10 images in bed class, 10 in chair and 10 in table class, right? So out of these 30 images, we will use, you know, 80% data to train our algorithm and 20% data to test our algorithm. So 80% means we will be having 24 images in train folder and 6 images in test folder. All right, so this is what I'm doing over here. So in this for loop, I'm writing this loop, and if you'll see this loop, 80% data I'm storing in train folder, and using this I'm storing 20% data in test folder. Now if you'll open train folder, so you'll be having 24 images, max images, bed, image of bed, and then you will be having images of table, you'll be having images of chairs. So we are having 24 images over here, and you'll be having this 5 or 6 images in test folder, right? How we get this thing? By executing this loop. All right, now okay, over here I have shown you by using the length method. I've shown you like 24 images are there in train folder and 5 images are there in test folder. So if you remember, I have shown you this screenshot in the beginning of our today's class, like we will be having a data in the form of CSV file, and CSV file should be in this format. So now we have two folders, we have divided our data into train and test. Now the next task is to store the details of the images which are present in train and test folder in CSV file. All right, so this code over here, this code, using this code, first of all over here you'll see I have created one variable, and I'm creating a data frame over here, and the column which I want to have in this data frame, these column name, file name, xmin, xmax, ymin, ymax and class name, right? So basically I'm creating a data frame, and these are the columns of those data frame, and now I'm accessing the directory right? The directory train path. In this variable I have given the path of my train directory. See over here. So this is the path of my train folder and this is the path of my test folder. Okay, so now what I'm doing is give a path of my train folder and one by one it will store the details of that in this data frame train_df. Alright, and now train df.head, you will get a data in the format which is required. This is the format which faster Rcnn will use, right? And after that, okay, I'm plotting and showing you the results. See over here, train df is a data frame, file name. See over here, if you remember this plot bbox function, the function which I have created in the beginning for plotting the bounding box, I'm using that function, and by using this line I'm getting the IDs and I'm plotting the bounding boxes. See over here, this is showing us random results from it, right? In the same way we will perform the functionality for test data also. So the same code I have executed for test. The only difference is our test_df is a variable where I'm having a data frame which will be storing the data of test file. And then now what I've done is basically train_df and test_df are two data frames, right? So now I'm converting the data which is present in train_df and test_df to train.csv file and test.csv file, and these files will get created over here, train.csv file and test.csv file. Let me open train.csv file and show you the results. See, this is train.csv file name xmin, xmax, ymin, ymax and the class name. Now we have our data in the format which faster Rcnn will accept. Alright, so okay, now the last thing which we need to do, we have done till here, right? We have data in this format. Now we have to create annotation files also, right? So we will be having two annotation files. One annotation file would be, okay, see, I'm writing train.csv to annotation.txt file. So this is the code. I'm creating one file with the name of annotation.txt and I'm getting the data from train.csv and I'm storing it in annotation.txt. And the same way I'm creating another file test_annotations.txt and I'm storing the data which is present in test.csv in this annotation file. So let me show you that also. See over here, test annotation.text and annotation.txt. Let me open annotation.txt for you. So this is the data which is present in annotation.txt. So now if you'll see this, these are the files in total which you will get after preparing data for faster Rcnn. So this, let me again tell you, this file and this file, these three files we have downloaded from internet. And then bed, chair and table, these are the three classes, these are the three folders, because we have used the subset of this data set. So we are working on these three different classes, so that's why we have these three different folders, and we have limited the number of images to 10. So that's why each of the folder is having 10 images. Then we divided our data into train and test. We have created these two folders manually. These three folders will get created itself, but train folder and test folder we have created manually. Then we have written a function by which we are sending 80% data to train folder and 20% data to test folder. After training and testing, we want to store the data in the format which faster Rcnn accepts, right? So train.csv and test.csv we have created, right? And after that we have created annotation and test annotation file. This is what faster Rcnn, this is what faster and CNN needs to work upon. Now in my next video I'll show you how to use faster Rcnn algorithm. In my today's video I've explained you how to prepare the data for it. So once you prepare the data, now we can simply execute the algorithm, faster Rcnn algorithm on it. So guys, if you like the video, please subscribe my channel and share also. And in my next video I'll show you how to practically implement faster Rcnn. And I will recommend you one more thing. If you are new to faster Rcnn and if you are not familiar about the theory part of it, so I'll mention one link in the description section which will take you through the basics of faster Rcnn, because it is very important always to understand the logic of the algorithm before the implementation part. That will help you out in understanding the coding part if you know the basics of it. So I'm giving the link in description section, go through it. Thank you.